Introduction again. So, okay. Yeah. All right. So today I'm going to present on a topic which we had been working for the past 7 or 8 years almost. So we are looking at the footwear or the shoe, which is a which is of common use for all the individuals, and something which we often skip is slips and falls. So that is my area of concern. So today I'm going to talk about state of the art of traction or friction characterization of footwear sole materials. What is the from a material standpoint or structural standpoint, how does the footwear stand? How do we test it? So that is what I'm going to present, and this is part of the ongoing research which is being conducted at my lab right now. So let's get started. So today I'm going to take you through the introduction briefly, and traction performance of formal footwear. I'll discuss from a direction of traditional skid tester or skid testing. So what are the traditional methods which are used for friction testing? And then we will discuss about development of a novel device which is known as a biofidelic slip tester. How this device is novel and how this is going to change the direction of traction testing. So this is the next thing which I'm going to discuss. Then we will present traction performance of formal footwear, because this is commonly a standard, utilizing this new tester. And then the next step is we will try to understand the science of how the tread pattern or the varying tread shapes and directions in your footwear affects the friction. That is the next thing which we are trying to understand. And the last thing which we want to understand is the effect of possible floor coatings. So we know flooring has an effect on the footwear friction, but what about floor coatings? Does it affect? And then we are going to finally wrap up with some conclusions and references. So that's the structure of the things. I'm not going to take over 45 minutes, so I'll try to finish on time. So let's start with the introduction. So what is meant by the term slipping? So slipping essentially occurs when there is too little friction between the footwear or the foot and the floor. So if you are barefoot, then it's the foot and the floor. And if you are with a footwear, so it's the footwear and the floor. So typically when the amount of friction goes below a certain value or limit, you tend to slip. The person's heel on the front foot slips forward, causing the person to fall backwards. So basically, if you look at the diagram on the left, so this is your initial stepping in. So you're going to technically step on a puddle of fluid, like it could be water or some kind of cleaning liquid which has been left behind by the cleaning staff, or there is some slippery flooring, and your foot begins to slide, and finally you lose your control, and then the foot accelerates, and due to discrepancies of the 2 foot, like you tend to fall, right? And this fall can lead to several implications like fracture and back pain. This is very common for elderly population as compared to much more young population, because we have a better control on our body, but it kind of diminishes in terms of control as you age up, right? So slip and fall is a very common occurrence. I'm sure all of us have at least slipped, if not we fell down, and there are instances we have fallen down like at least a few times a year, due to some very slippery floorings which are in your institute or somewhere else, right? So this is a very common problem, and this slip typically occurs when you have a heel strike or you are going for a toe off. So slip usually doesn't happen when you're pressing your complete foot down, like your entire foot area is on the ground. That is not when slip happens. It usually happens when you're about to step or about to step off, right? So that's typically when the slip happens. So slipping might also lead to a very injurious fall, and this can lead to a head injury. There are so many implications. So what are the key causes and causes of slips and falls? So wet and oily surfaces, this is very common. We can encounter a very wet and oily surface, like oily surfaces, for example, kitchen. Very commonly you can have, so would you be wearing a shoe in the kitchen? That's another question. So in big hotels and restaurants, a lot of workers are just running around to serve food within a certain time period of time, and there are oil spills and oily surfaces, so there is a high chance of slips and falls, right? So there are a lot of places in which you would encounter oil, and wet surfaces are very common. So it's just a nicely, cleaned floor, which might have like a layer of soap sud or layer of water or some kind of a cleaner, which is there. Smooth floorings. This is another problem. So in the picture in the middle, you're looking at a very, very smooth flooring. So if you look at flooring, one flooring to another, certain places like bathrooms and other places, you will have much more coarse floorings, where if you step, you don't feel like you're going to lose your control. But there are places where it will be extremely marble kind of flooring or glossy flooring, which is extremely smooth flooring. There also, there is a high chance of slips. Balance and gait disorders. This is a little less unlikely, but you can still have balance and gait disorders that you're not able to walk properly, right? Like, and you tend to slip. Side effects of certain medications. So also there could be certain medications which impede your ability to walk normally or have all the sensory motor control that you're able to perform your gait functions, right? Effect of aging. With aging, of course, your gait changes and you tend to slip and fall very easily. Distractions or perception of the walker. So there could be several distractions and you tumble over something. So so these are some causative factors of slips and falls. So let's get a little bit more and more depth into the science and exactly what is happening into this footwear floor problem, and then we will get into the material side slowly and steadily, right? So essentially, there are three things which are of concern from a physics standpoint. You have the footwear, you have a contaminant in between, and you have a slippery surface, right? It could be slippery or non-slippery, and due to the contaminant, it gets slippery. So that it's the interaction between very complex and nonlinear interaction between these three materials. Let's note, surface is a hard material, so you're looking at a completely hard material. Contaminant is a fluid material, and shoe soles, which is the bottom of your shoe, is typically a soft material, which is deformable. And so you're having a soft hard material interaction with a fluid in between. That's kind of the physics which we are trying to study, right? So let's have a quick glimpse on the worldwide statistics of slipping. So each year, roughly 700,000 to 1 million patients fall occur in the US hospitals. This is a very common, statistics, resulting in around 250,000 injuries and up to 11,000 deaths. So we usually go by US statistics because it's a commonly reported statistics. But even in India, the scenario is same. If you look at the UK, huge amount of slips and falls. And so specifically, we have put the hospitals here because we started pilot testing in the hospital. We are jointly affiliated with AIIMS, so that's why we started testing at different corridors and different floorings of the hospitals. So we started focusing a little bit, but this is a problem in the offices, problem in the hotels, problem in the shop floor. Like shop floor, where you have a heavy manufacturing industry with a lot of grease and oils which are falling, like, a lot of formal footwear may slip and fall, right? So slip, trips, and falls are the second most common cause of both fatal and non-fatal work-related injuries in the United States, leading to significant amount of US workers' compensation claims. So what is this workers' compensation claims? This is also getting more common in India. So this is typically if you fall or if you get injured at work, the particular company you're working for is supposed to pay you a huge lump sum in order as a settlement of not having the right safety conditions, right? So this is getting very common. So this is known as a US workers' compensation. This is getting very common in the multinational companies or US-based companies or Europe-based companies in India as well. So if somebody gets injured at work due to your unsafe workplaces, you need to pay a hefty lump sum, and this can go to millions of dollars even, like of settlements, right? So a lot of law firms are also interested in having a very safe environment for most of the workers. So that's why this event or the slip and fall issue becomes even more important. Besides the injury and possible deaths, it is also monetarily draining for a lot of companies. So that's why the world statistic kind of points towards the importance of doing more slips and fall studies on the footwear. So let's look a little bit into the biomechanics of slips. So typically what happens is you basically place your foot like at a certain angle while stepping, and then there is a reduction in friction within that between the foot and the ground, the footwear and the ground specifically here. And then you either encountered a mini slip, which is where a person doesn't really detect the slipping motion, but you could get a little bit of like push or acceleration to your footwear mid slip, where you can still recover from a slip, and then you have a macro slip which you cannot recover from, right, which is going to lead to your possible fall, or you could hit your head or get injured and whatnot, right? So these are some force diagrams. Like usually accelerations and vertical ground reaction forces are kind of measured over time. So typically a foot motion is given by one peak, if you look at the vertical ground reaction force while you step, and then during the toe off there is another peak. So this is usually happening between the first, either during the first peak or the last peak. So that's during the time of heel contact, and this heel contact time is as low as a few, it's much more lower than a second. So it's, you're looking at milli or microseconds here, right? And within this short span of time, you can get a slip. So typically, how slip is usually measured, or the footwear traction is measured, is using a gait lab or a gait analysis. Call this as a human subject study or human slipping experiment. So what typically happens is you have a huge walkway, and there is a person who is fit with a lot of markers, and you have a gait measurement system, which is basically comprising of cameras, IR cameras, infrared cameras, which will more than 16 or 18, which will measure your gait. And then you have a force plate or a force platform, which will measure your forces. It's a 6-axis platform, which will measure your vertical as well as shear forces, and give you vertical by the shear. Basically, the ratio of the shear and the vertical will give you the coefficient of friction, right? So that is how typically the slip experiments are performed. But if you look at the shortcomings, it is extremely cost and time intensive. So you need to basically carry out these experiments for a very large span of time. So one person has to be fit with markers, they have to be trained, there are certain walkway rules and regulations, usually a few hours of work. So we did a lot of experiments while I was at University of Pittsburgh. Like there's a huge gait lab, so we did like 230 experiments over a span of 1.5 years, right? Like, so that takes a lot of time. It needs a very sophisticated gait lab with cost of multi-crores, and this is ethical and biosafety issues. So a lot of ethical and biosafety issues are also there with human subjects, and collecting the adequate number of data. So you cannot have a person walk on 15 floorings, right? It is not very easy to change the flooring underneath. So this is not a very cost-effective method. So just for one person, you will have one flooring with one contaminant condition, 2 hours. So that's a very large amount of characterization time for footwear friction, right? So that's why human slipping studies are extremely cost-intensive, and they are not very often considered as an industry standard for studying the footwear traction. So the next best thing is to develop a mechanical slip testing device, where basically, and this has happened historically, this is not something which we developed, but mechanical slip testing devices have been around. So what they do is they typically simulate the biomechanics of your foot. So basically, if you look at this device on the left, so this is vertical motors, which are going to apply a vertical ground reaction force similar to the weight of your body. So let's say if I weigh 60 kilograms, this is going to place around 30 kilograms on one foot, right? And then you can place any kind of floor cutting or flooring underneath, and then there is a force platform underneath. So then this shoe can be adjusted in different angles. So there is an angle adjustment setup and can also be moved horizontally. So you can replicate the entire biomechanics while you're walking and about to hit a possible slip, right? So that is being replicated, and during that replication, the force plate measures the shear and the normal force, and the ratio of that over a dynamical range of 200 microseconds will give you the coefficient of friction, right? So with this existing device, there is still a range of problems which are there. One of the key problem is testing the biofidelity. Biofidelity means basically that actually replicating the biomechanics of a foot, right? So even though these devices are able to replicate some biomechanics of the foot, still the different motions which need to happen together. So while I'm about to slip, I'm not only placing my foot underneath, I'm also trying to move horizontally. So simulating all this biomechanics in one portion is very, very important to get the right material characterization for the shoe and floor. So this is very, very important. Second part is, and this is known as environmental fidelity. Environmental fidelity in this case specifically means the actual flooring. So here I'm cutting out a flooring like from somewhere, but this is not a real walkway or a real flooring. So can you use any of the existing device in a real flooring? So the answer to that is no, because you need a force plate underneath. This is not a setting which will allow you to place this device on a realistic flooring, right? So that's why these mechanical slip testing, even though they are the industry standards, there are still these two issues of biofidelity and environmental fidelity, which needs to be addressed. So the main attempt of these devices are to simulate the dynamics of the foot slip in order to achieve biofidelity, but that's not very common. You can see a device on the right. This is a device from the University of Toronto. This is where they're trying to measure the shoe and floor friction in presence of ice. You know, these are ice sheets, and they're trying to look at snow, ice, and dry ice. Dry ice is where you cannot see the ice, but the floor is completely frozen. It's extremely slippery condition, right? So they're trying to do this with such a huge and bulky device, right? They have measurement units on the top and the force plate is missing here. So usually these devices are fairly expensive. They're complex to build, and they can take a huge amount of cost. Yeah. So a wide range of mechanical slip testing have been used to measure friction, but they still lack in terms of their accessibility or usability in middle income countries such as India or the Middle East and other places where these are not widely accessible. You know, these are mainly done in the US and Europe. So these are some other examples just from a literature review standpoint. You know, one of the common testing devices known as a British pendulum testing or a British portable skid tester. This is the last one which you're seeing. If you have ever worked with the airport authority or have looked at friction testing, you would have come across this British pendulum skid tester. You know, this is a very simple piece of device which has a kind of a pendulum kind of arm, which has a small sensor. It's known as a sensor, but it's a rubber pad which essentially mimics a possible something like it is used for usually tires, like for all kinds of this airplane tires. So they basically look at the friction of the airfield while the landing, but this is sometimes used for the footwear friction testing as well. But here you can see, once the biomechanics is not correct, of course the foot doesn't swing like this, and second is this material which they're using for characterization is typically not correct. It's just a piece of rubber. So it will not give you the right piece of information in terms of the footwear floor interaction. It just gives you the information about the flooring. So there is one or the other discrepancy with all the slip testing devices. So that's the summary. And even though they are very complexly built, they are not solving the overall purpose of biofidelity and environmental fidelity. So that being said, I'm going to talk about the traction performance with the skid tester. Very briefly, what has been covered so far. Taylor et al. This is one of the major groups is in University of Pittsburgh, where they basically do a lot of this footwear testing using two different slip testers as well as human slipping studies. So basically, I'm going to skip over the details, but just summarize the points. So few things which have been found to be important: the footwear treads or the bottom pattern, that becomes really important in imparting a certain amount of friction which is necessary for the footwear and the floor. And one of the key drivers to that is not only the design of the treads, but also the contact area. Another component which is of importance is the heel width, because usually when you're hitting the ground whilst about to getting a possible slip, you're basically hitting the ground with the heel. So that structural components in the heel width and how the heel is built is of primary concern, right? And also the hardness of the heel. So what is the hardness of the material of the heel? If it is super hard, like high shore hardness of PU, then it's a different material. Low shore hardness of PU, it can deform. It's a different material, right? So these factors affect the footwear and flooring friction a lot. So that is something which we have looked at. There is something in the chat box. Yeah, okay, never mind. So there is also variation in tread geometry and material hardness, which have led to ACOF is nothing but this is known as the available coefficient of friction. This is just a way of mentioning friction during shoe tests. So I'm not going to get into the available and utilized coefficient of friction. These are different terms, but let us just think about friction in general, right? So what they have found through the study in Journal of Biomechanics, this is again the Pittsburgh group, they have found 87% of the tread geometries and material hardness differences have accounted for COF or friction variation, indicating that the tread patterns or the tread material has a huge impact on how the footwear and the floor behaves in general. So there is a quick question, does surface roughness and contact geometry effects? Yes, there is an effect of surface roughness as well. The contact geometry is also of use. So this is a very complex nonlinear problem. So the surface roughness will give some point of contact geometry as well as the shoe contact geometry, how it kind of after the loading disperses on the ground, that has an effect. So that you are correct in saying that. Yeah. So let's go further. So then there are some works from our group where we have looked at, so what we wanted to do was we, rather than testing the same footwear on 10 different floorings, we wanted to find some generalizable values saying that, let's say these 10 floorings or this group of three floorings behave similarly for a certain footwear. So we did some generalizability study. So there has been a lot of shoe testing. We have tested more than 600 pairs of shoes in the US. Currently, we are building several devices and we are working in India in IIT Delhi. So specifically, we are working on around 200 pairs of shoes and we are doing a massive testing for different population like clinical population, the hotel population and other people. So I'm going to skip over this literature review, but few things which are of real importance, which are as I highlight, the dynamics of the heel also has a significant effect on the slip resistance. So this is the biofidelity component. So how the slip dynamics, what is the velocity of a slip, what is the angle of a slip, as well as what is the load being offered like here. So this has a huge implication on the slip outcome or the final traction value. So if a device is not applying the right load, right angle, and the right speed of slipping, it is going to give incorrect value. So that's the biofidelity. Second is the right flooring. That's the environmental fidelity. So these are the two things which are currently a research gap. So this is using the skid tester. I'm going to quickly just go over the results. Like, here we have tested different kind of footwear heels we are looking at. We have kind of taken an imprint of that and remade that. And we have created a foot model using 3D scanning and kind of attached a shoe cut out with the sole, and we have placed the specific sole here underneath to test what is the effect of the overall foot, because we wanted to not only have the thing swing but also have the effect of foot, because foot has a certain shape, right? So we have the foot in, a foot simulant in with the footwear out with the particular sole, and through imaging we have also looked at the tread area which is in contact, right? So we have put a small kind of a colored imprint where we have looked at the tread area which is in contact during this interaction. So here we have come out with some ACO values. So where we have looked at the different tiles, matte tile, glossy tile, anti-skid tile. We can say glossy tile is the lowest coefficient of friction, matte tile is in medium, anti-skid is usually very high friction. So we have specifically tested the different shoe patterns. So B1 to L3 are the different shoe patterns at the different tiles. So these are the three different verticals which you're seeing here, and we have seen several ACO values. The key highlight, it was observed that the outsole, so the vertical and oblique tread orientations showed higher ACO compared to other outsoles. So one of the key findings which we got, so towards your direction of walking, if your treads which are pointing towards that direction, then they have a high friction value. Also at treads which are a little oblique, like let's say at a 15 or 20 degrees facing towards your direction of walking, they also have high friction. So this is one of the very interesting findings which we have got from a lot of tests here. as compared to treads which are completely horizontal. So if you just check your footwear and see horizontal treads, you may have a little lower friction than if you have vertical treads. By vertical treads, we mean treads pointing towards the direction of walking. So this was a very interesting find. Another find was the coefficient of friction of outsoles having maximum reduction of around 62% across all the tiles in presence of a Lysol. Lysol is a very common cleaning liquid. So in dry slipping condition, the slip conditions are very unlikely. Even with water, sometimes most of the footwear do not slip. But when you change that with some kind of a cleaning liquid like Lysol, there is a huge chance of slip. So that is something which we observed in the Lysol condition, right? Some other findings, the ACF of the shoes further reduced up to 50% on all floorings with liquid soap as a contaminant. So any kind of soapy kind of liquid like soaps, shampoos, or Lysol solution, which is a high viscosity, any kind of high viscosity fluids will lead to a very high chance of slips and falls and a very low amount of traction value. Okay, one thing to note here, you're looking at some coefficient of friction values, what is good and bad. So typically from the industry standards, and we have also contributed to this industry standard, what we have found out is if the coefficient of friction value is below 0.3, you have a high chance of slipping. So that's a very common standard. So there is a quick question. The analysis is for walking conditions. How will this change for running and sports? So that's a very good question. So basically how this will change for running and sport is the loading will be different, because in running you are applying a different kind of loading and the angle of the shoe also changes. So while you're doing brisk walking, the angle would be much more lower with the ground. While you're running, the angle kind of changes. So the angle and the force will change, and also the speed at which your shoe basically accelerates, that will have an impact. So if you change these three biomechanical parameters, your basically the testing results will also change. Like, hopefully that partially answers your question. So these are some of the parameters which will change from walking to running, but typically we don't measure for running because we have not gotten into the sports shoe regime yet. And that's the next big thing in our pool, like, or part of the future work where we will get into all kinds of sports and athletic shoes where slipping and falling have different implications, right? There you are not only looking at the translational friction, but you could also have a rotational friction where your foot completely twists. So that's a little bit different regime where we would be looking at in future. Another finding, getting back here, similar traction behavior was observed for majority of the outsoles for oil contaminated floorings. This is also a very interesting find. So when you have oil on the ground, it doesn't matter what flooring you have. So, or it doesn't matter what shoe you're walking with. Your coefficient of friction goes very, very low. And if you look at the graph on the bottom, you're looking at 0.1. All the coefficient of frictions are less than 0.1, irrespective of B1 to L3 different shoe patterns, irrespective of the tiles. So that essentially means that with oil, you have a very high chance of slipping with most of the existing shoes. So these are very general public implications. This is not something very specific, which will not occur to me. This can happen to me or you, like, right? So going further, these are some further results where we looked at that the vertical and oblique tread patterns is I've already highlighted. So let's move into the next slide where we have a biofidelic skid tester. We are going to talk about, so this particular biofidelic skid tester which we have developed. Let's talk about this. So this is a very advanced device. This is currently filed for patent, developed in IIT Delhi. This device, the key importance of this work is this is portable. You can take this device anywhere. This is rollers. I can just take this device to your particular lab. I can take this to any shop floor, any industry, any hotel kitchen. And basically this has load cells rather than the force plate. So I have a series of two load cells. One is a horizontal load cell and one is a vertical load cell. I have the angle adjustment set up. And basically then I can place any shoe here and test it within just less than 10 or 15 seconds. So adjustment is usually around 30 seconds to a minute. And then on a display, it will give you the average coefficient of friction. So this is a very advanced device or robot which we have built in our lab. And this is conforming to the ASTM F2913 standard. This is the footwear traction testing standard. This is very important. If we do not comply with the standard, the device is of no use. So this is very stringent, dimensions. Like these are all in, you're looking at meters, and then horizontal speed is usually around 0.5 meters per second. So that is the speed of sliding. The maximum displacement you're looking at is around 30 centimeters. That's the maximum displacement. Vertical forces which this device can apply 0 to 500 newtons. And the angles at which we can test the shoes goes from 0 to 30. Typical foot angles while slipping has been measured to be around 17 plus minus 2 degrees. So that is what we have found out from our human slipping experimental studies. The weight of this entire device is around 60 to 80 kilograms. Right? So this can handle both horizontal and vertical loads. This is handles to push it and lockable wheels, right? So I'm going to spend, I know the time is limited, so I'm just going to quickly go over some of the results and kind of wrap it up. So these are the 4 steps which is this particular device is going to basically take us through. This is some advanced study which we are doing. We are testing a lot of different shoe patterns, like generalized shoe patterns. We are going into Bata, we are going into, Khadems, and like several other standard brands like Hush Puppies. We are looking at all this particular shoe brands and picking up a few shoes like formal, and we are trying to characterize basically the shoe floor friction. And in the future, our goal is to have a complete website with a detail of what shoe has how much friction in a very slippery flooring versus a normal slippery flooring. So this will hopefully help the public to select a certain footwear based on slipping potential. For us, it may or may not be important, but for particular companies which are in bulk buying footwear, formal footwear for, let's say, workers or nurses and whatnot, so for them this would be of increasing importance. They can quickly go through this chart and see that this footwear has a frictional value less than 0.3, so most likely this is going to have high slips and falls. So this is our future work. This is a snapshot of a CFD based study. So this is computational fluid dynamics study, where we are basically looking at the contaminant flow patterns while this shoe is sliding. So this is a fluid structure interaction study where we have looked at while this footwear is being like pushed by the floor, and the flooring is instant, and then there is this fluid flow going through. How are the fluids coming out? What is the mass flow rate, and what is the fluid pressure? So there is a huge implication of the fluid pressure on the friction. So high fluid pressure basically means lower friction. So if we look at very horizontal treads, the entire fluid is not able to come out. So from a tribological standpoint, if the fluid is not able to flow, the amount of friction goes down. If the fluid is completely able to flow, then the friction goes up. So that's why this is the science behind it. That's why we saw in vertical tread patterns, which are facing towards the direction of your walking, we see much more higher friction. Sorry, my bad. So much more higher friction for treads with vertical patterns. For horizontal patterns, the friction is much more lower. So you have a high chance of slipping. Right. So next time you can watch out for the shoes which you are wearing. We are looking at a marketing standpoint. So I'm interested in entrepreneurship as well. So we looked at the entire footwear market, and these are some injury lawyers which would charge millions of dollars for any kind of workers' compensation. This is a comparison of all the devices in the market right now, going from James device to the Satra STM 603, which is the most closest device to our device, but it is still not portable. So it doesn't have all the sliding speeds, so the first 3 conditions, forces, sliding speeds, and the shoe angles, conform to the biofidelity. Can test the whole shoe. This is also a very important. Do you have a shoe cutout or a small, just a piece of the sole versus the entire shoe? Entire shoe is much more biofidelic. Then there are other parameters which basically make sure they conform to the standards. And if you look at the cost overall, average cost is 20 to 30 lakhs, like for any device in the market. Again, they're not portable. And our solution was built less than 2 lakhs. So this is what, and we are trying to sell this through a tech transfer for more than 10 lakhs, and hopefully through a possible startup channel. So few of the key USPs of our product includes the lowest cost. This is the first portable device in the market, and all the input and output parameters are ASTM standard compliant. This is not the case with other devices which are there up there, right? So I'm just going to talk a little bit about here, like very briefly. So across all the shoes tested, some of the important key features of a new testing device is it should be able to clearly differentiate between two different shoes on the same flooring and same contaminant condition. It should be able to differentiate between two different floorings given the same shoe and the same contaminant condition. Again, it should be able to differentiate between two different contaminants with the same flooring and same shoe. So it should be able to distinguish between floorings, contaminants, and shoes independently as well as when they're in combination. So all these tests were being conducted. So I'm just going to skip over this test results in the interest of time, but this is what these tests are about. Like, we are trying to see if the slip tester is able to distinguish all this. And for higher friction shoes or a very high traction shoes, is it showing high traction or is it showing a false value? So a lot of this repeatability tests are important. Same shoe has to be tested at least 5 times, to make sure what is the average value, right? So these are some test results. Also, we are running some correlation between, so if you look at the first figure here, we are looking at coefficient of friction versus the contact area. So we look at a very high correlation. So when the overall contact area, so contact area means the bottom part of your footwear which is touching the ground. So that's the bottom part of your tread pattern. If the contact area is very high, usually the coefficient of friction is fairly high, right? So that is something which we found out from this particular thing. Shore hardness. So if the hardness of your shoe is very high, then usually your slipping chances are much more higher than the coefficient of friction is low. So you need to have a soft material with a high contact area and with possible vertical treads. So these are some key findings from these studies on the formal footwear, which we can use in the future works. We also wanted to actually understand the science of footwear by systematically modifying the footwear. So I'm going to skip over the literature. Very few studies have systematically modified the footwear. What do we mean by systematically modified? We have just focused on horizontal and created different tread depths and tread sizes. If all these treads are artificially built and they have been done in different widths and different channel depths and channel widths, right? So with different combinations, we did a parametric study to understand what is the effect. Now, let's say we have horizontal treads on our footwear. Now, what horizontal is good, what horizontal is bad? So that is what we wanted to find through studying the science. So we did find out that in certain, higher intervals of treads on these outsoles could have led to overall increase in the ACUF. So typically for horizontal footwear treads, like I'll give you the summary, we did not find a huge amount of difference. Most of the horizontal footwear treads are equally bad. They will cause your footwear to have low amount of friction and high chances of slipping. So the overall ACUF in wet slip testing exhibited a near generalizable trend. So the horizontal tread pattern doesn't matter if it is the interval of the tread is very high versus the tread gap is very low, right? So this is a very important finding. We did the same for vertical treads as well. So in vertical treads, we found out there is a huge implication. So we saw that outsoles, I'm going to come here. So this is due to increase. One is contact area, second is drainage channels. So we are calling this as drainage channel. The more drainage channel or drainage of fluid you can have, the higher the friction of your particular shoe. So basically, if you have wider channels, you will have a much more higher friction. So next time when you go to purchase a footwear and you're interested in slips and falls, please look out for these features. So that's one of the key takeaways. I'm not going to, I know I'm skipping over time, so I'm just going to quickly go over. The last thing which we did was we did some coating study. We wanted to see, can we modify a particular flooring with certain common coatings like HN coating, epoxy coating, polyurethane coating, and we have selected some very high traction boots for this study. So some of the key things which we found out was, there is a key difference between, the different floorings. So slip testing experiments across dry, wet and floor cleaning solutions on uncoated laminate floor, of course, has a high slip risk, and the ACUF of less than 0.3. Floor coated with HN showed significant increase in shoe floor friction. So there is giving an answer to one of the questions earlier. So with this particular coating, we are changing the characteristics of the particular floor. So this characteristics change is going to affect the overall friction, right? So floorings coated with epoxy paint showed good slip resistance performance as all shoes were able to cross the threshold of 0.3. So epoxy paint was also pretty good for most of these slippery floorings. Floorings with thick polyurethane coating observed also high slip resistance performance. So yeah, basically we did a comparison study. So that's it. Like, to overall conclude, we discussed some slip testing methods. We did some literature review on the slip testers, and based on that, we conducted some initial tests with a traditional skid testing device. Then we developed, based on the gaps of biofidelity and environmental fidelity, a novel biofidelic portable testing device, which is the first of its kind ever in the country and across the world. And we are trying to make this into a startup form. And we are also interested in collaborations where somebody is interested in shoe testing with shoe manufacturers as well as researchers. And we have tested a lot of standard formal shoe testing was conducted in AIIMS Hospital. We have done a lot of clinical population nurses. Next, we are trying to look at some of the restaurant workers, like the chefs and cooks, who are wearing the same kind of footwear, and we'll be also focusing on the industry, and we are interested in the offices. Then we started to understand the effect of tread patterns or the treads on friction, and what is the science behind it. So we have come out with several scientific findings, such as a soft insole is usually good, soft outsole is usually good. So the hardness of the outsole should not be very high, right? The tread pattern should be typically vertical, so, and the contact area of the tread pattern has to be very high and typical vertical with a higher tread channel gap or a tread channel width is going to give high friction to the footwear. So these are some of the scientific findings, and we are doing some follow-up computational fluid dynamics studies to understand in depth the science. And we also looked at the effect of floor coatings, that what is the effect of floor coating on this. Now, the next thing which we are going to study in future is CFD studies to understand the individual effect of the flooring, shoe, and the contaminant on the overall friction. What is affecting the most? Is it the shoe or is it the flooring? Then we can conclude certain things. And we are also interested in wear studies. So when you wear your shoes for, let's say, 6 months to a year, you have a certain natural wear to your shoe. Is it still okay to wear that? Or are you going to slip and fall in that kind of, because the contact area has now changed. The shoe has got worn out. Some of the treads have got eaten up. This is very important for athletic shoes as well. You cannot be wearing a shoe after 6 or 7 months, because while running, you may fall, right? So this is just as a conclusion and future work, and there are some references, and that's it. Thank you.